In this session, I'm going to explain about the problems on H parameters. So this is the problem. I need to find the H parameters. So for this two-port network, in the two-port network shown in figure, compute H parameters from the following data. With the output port short circuited, that means whenever V2 is equal to 0, this is the data that he obtained. V1 value is 25, I1 is 1 ampere, I2 is 2 amperes. With the input port open circuited, if I1 is equal to 0, this is the data that he obtained. So for this type of problems, how to solve this problem? You see, normally these H parameters, so V1 is equal to, so how to write it in V1 and I2 should be equal to H11, H12, H21, H22. This is I1 and V2, I1 and V2. So if I write this matrix form into equation form, V1 is equal to H11 I1 plus H12 V2, and I2 is equal to H21 I1 plus H22 V2. Now I need to find the values of this H11, H12, H21 and H22. So to find these values, H11 is equal to, it is I1 divided by V1 at V2 is equal to 0. You know this, H11 is equal to, if I make V2 is equal to 0, it is V1 divided by, it is V1 divided by I1. V1 divided by I1. And H21 is equal to, it is I2 divided by I1 by making V2 is equal to 0. That means if the output port is short circuited, V2 is equal to 0 means output port is short circuited. Then these are the values of V1 and I1. So V1 value is 25 volts. So 25 divided by I1 value is 1 ampere. At V2 is equal to 0 means output port is short circuited. So H11 value is 25. And H21 is equal to I2 divided by I1 whenever V2 is equal to 0. That means whenever output port is short circuited, I2 value is, it is 2 divided by I1 value is 1. So it is 2. So H11 is 25 and H21 is 2 here. Now it is next H21 and H22. How to calculate this H21 and H22? So H21 is equal to, it is I2 divided by I1 whenever, H21 just now we calculated H21. Now I need to find this H12 and H22. H12 and H22. H12 is equal to, it is V1 by V2 at I1 is equal to 0. If I make I1 is equal to 0, I can calculate H1 is equal to V1 by V2. H22 is equal to I2 by V2 at I1 is equal to 0. So H22 is equal to I2 by V2 at I1 is equal to 0. So I1 is equal to 0 means input port is open circuited. That means H12 is equal to, now this is the values, that is 10 divided by V2 is 50, H22 is equal to I2 is 2 amperes divided by V2 is 50. So it is 1 by 25. It is 1 by 5. So H12 is equal to 1 by 5 and H22 is equal to 1 by 25. If I write it in a vector matrix form, H11, H12, H21, H22, that is equal to H11 value is, this is H11 value is 25, H12 value is 1 by 5, H21 value is 2 and H22 value is 1 by 25. So this is how we need to solve this type of problems. Now another problem here is, this is the another problem. We need to find the H parameters for this network. So if I write this, so it is the network which has to be converted into frequency domain network or S domain network. So for that I am going to redraw this network in S domain. So the value of the capacitance here is 1 by 2 farad, 1 by 2. Here it is 1 by 2. So if I convert it, it is 1 by Cs, 1 by Cs. So 1 by C means C value is 1 by 2 into S. So it is 2 by S. Here it is LS. LS means 1 into S. So this network, if I draw this network in S domain, will become like this. It is plus minus, it is V2, it is I2, and this is I1, plus and minus, it is V1. Now this value is 2 by S, this value is also 2 by S from this, and this value is S and it is S here. So now what I need to find here is H parameters I need to find. So from this data, V1, I2 should be, these variables can be represented in terms of H21, H2, in terms of I1 and V2. So this is V1 is equal to H11 I1 plus H12 V2. I2 is equal to H21 I1 plus H22 V2. So I need to write the network equations for this network in this form. For that I am using this, first you use this, let us consider this voltage is, we know that it is, this voltage is this voltage V2. So this voltage is V2, and this voltage is not equal to this voltage. Let us assume the voltage at this point is, it is V3, and at this point is, it is V2. Now let us write this KVL equation for this loop. So for loop 1, so V1 is equal to I1 into 2 by S plus, it is V3 divided by S, right? V3 divided, sorry, it is V3. This voltage plus this voltage is equal to this voltage. So let us represent, let us assume it is 2 by S, so it is 2 by S into I1 plus V3. Let us consider it is equation number 1. Now I am using the another, I am writing another equation using the nodal analysis or the KCL. It is I1 is equal to, this current is equal to this current plus this current. So here I1 is equal to, this current is V3 by S plus this current is, the potential difference across this one is V3 minus V2 divided by the impedance offered by this one is 2 by S. So it is V3 minus V2 divided by 2 by S. Now I can rewrite it as V3 by S into V3 minus V2 into 2 by, sorry, S by 2. So if I take a V3 common here, V3 into 1 by S plus this S by 2 minus V2 into S by 2, that is equal to I1. Now this V3 is equal to, if I write this V3 into this 2 plus S square divided by 2S. If I bring this term to the left side of the equation, it will become I1 plus S by 2 into V2. Now this V3 is equal to, from this V3 is equal to, this is 2S divided by S square plus 2 into I1 plus, this is 2S into 2S here. These two will get cancelled. So it is S square divided by S square plus 2 into V2. So let us consider this equation as 2. It is second equation. Now this, from this first equation and second equation, if I substitute this V3 value in this expression, this total expression will become in terms of V1 I1 and V2. So I need to write this V1 in terms of I1 and V2. Because of that reason, I am substituting this V3 in this equation number 1. Now this V1 is equal to, that means from equations 1 and 2, from equations 1 and 2. So V1 is equal to 2 by S into I1 plus V3 here is 2S divided by S square plus 2 into I1 plus S square divided by S square plus 2 into V2. Now if I take I1 common here, it is 2 by S plus 2S divided by S square plus 2 plus it is S square divided by S square plus 2 into V2. So it is V1. Now it is I1 into, if I cross multiply this, it is a 2S square plus 4 plus it is 2S square divided by S into S square plus 2, this one. If I take LCM, this is S square divided by S square plus 2 into V2, it is V1. Now V1 is equal to I1 into, I can write as 4S square plus 4 divided by S into S square plus 2 plus S square divided by S square plus 2 into V2. So if I compare this equation, so let us consider this equation number 3. If I compare this equation with this equation, H11, H12 into V2. Now the value of H11 is equal to 4 into, if I take 4 as a common, S square plus 1 divided by S into S square plus 2 here. Now H12 is equal to S square divided by S square plus 2 here. So I found the value of H11 and H12 from equation number 3. Now I need to write I2 is equal to, so for that I will write the nodal equation at node number 2. So at node 2, so it is at node 1, it is from KVL, it is using the nodal analysis at node this 3, at node 3. Now at node 2, so what is this node here? It is the second node here. So if I write the nodal analysis, so I2 is equal to, this current is equal to this current plus this current. So this current is V2 by S, so it is V2 by S. This current is the potential difference across this one, V2 minus V3 divided by 2 by S. So V2 minus V3 divided by 2 by S. So this is the equation now. So I need to substitute this V3 in this expression so that I will get this I2 in terms of V2 and I1. So let me rewrite this expression here. Is I2 is equal to, it is V2, if I take V2 common here, 1 by S plus it is S by 2. If I bring this term to the, so it is S by 2 minus it is S by 2 into V3. So finally this I am writing this expression again. I2 is equal to, it is S square plus 2 divided by 2S into V2. If I take 2S as an LCM, 2 plus S square minus S divided by 2 into V3. Let us consider this equation number 4. So from equations 2 and 4, so let us substitute this V3 value in this equation number 4. Now this I2 is equal to S square plus 2 divided by 2S into V2 minus S divided by 2 into V3. If I substitute this V3 here, it is 2S divided by S square plus 2 into I1 plus S square divided by S square plus 2 into V2. So it is this one. Now This is s square plus 2 divided by 2s into v2 minus this s into 2s. It is 2s square divided by, these 2 and these 2 will get cancelled, so it is s square divided by s square plus 2 into I1 plus this is s cube. So s into s square, it is s cube divided by s square plus 2 into v2. If I take a v2 as a common here in this expression, if I take v2 as a common, so v2 into s square plus 2 divided by 2s plus s cube plus s square plus 2 minus s square divided by s square plus 2 into I1. Now it is v2 into is if I s square plus 2 s square plus 2. So what I get here is, here I did a mistake while presenting this sign of this term here. So it is minus into plus, so it is minus, so it will become minus here. So it is minus, so it is minus here. Now you cross multiply these things here. So it is s square plus 2 whole square minus 2s power 4. This one 2s into s cube is 2s power 4. 2s into s square plus 2, and it is minus s square divided by s square plus 2 here into I1. Now this one v2 into this s power 4, it is s square plus s power 4 plus it is 4 plus 4s square minus 2s power 4. So here s plus 2 whole square, s square plus 2 whole square, this one divided by 2s into s square plus 2 is minus s square divided by s square plus 2 into I1. Now it is here this 2 and this 2 will get cancelled. While I am multiplying this term with this term, forgot to write this 2 here. So try to write this 2 also here. So it is 2. So if I cross multiply this one, so it will become 2 here. 2 into s square plus 2 whole square. So it will become 2s power 4, and 2 into 4 is 8. 2 into 4 is 8 here. So this 2s power 4, this 2s power 4 will get cancelled. So if I take this 8 as common here, it is s square plus 1 divided by 2s into s square plus 2. So s square plus 2 minus s square divided by s square plus 2 into I1. So this 2 and this 4 will cancel 2 4 times. So it is 4 into s square plus 1 divided by s into s square plus 2 into v2 minus s square divided by s square plus 2 into I1. So this is I2. Normally this I2 can be represented in h parameters. It is h21 into I1 plus h22 into v2. If I compare, let us assume it is equation number what is that equation number? Okay, so if I compare this equation with this equation, then h21 is equal to 4 into s square, h21 is equal to this one minus s square divided by s square plus 2, and h22 is equal to this one, that is 4 into s square plus 1 divided by s into s square plus 2. So if I write these h parameters in vector matrix form, h11, h12 is h21, h22 is equal to h11 value already we calculated here, This is h11 value already we calculated here, that is 4 into s square plus 1 divided by s into s square plus 2, and h12 value is s square divided by s square plus 2. h21 value is minus s square divided by s square plus 2. h22 is 4 into s square plus 1 divided by s into s square plus 2. So this is how we need to solve this type of problems. Here you see, so these two, I put these two here, these two and this two, it will make a 4 here, 2s into 2, so it will make 4 here, so it is 4, it is 4s, so it is 4 here, so 4 into 2 times, it is 2 times, 4 2 times, so it will become 2 here, so 2, so this is h22 is 2 into, so it is 2 into s square plus 1 divided by s into s square plus